Welcome to the channel, everyone. Today we are solving Leetcode 2487, removing nodes from linked list. So we're given the head of a linked list and we want to remove every node which has a node with a greater value to the right side of it. So we're returning the head of the modified list. And we can see from the given problem that we have the node 5 to 1338. And when we traverse the list, we go through 5. 5 has 2 next to it. Is 2 greater than 5? No, 2 is not greater than 5. We move on to 13. Now we see that 13 is greater than 5 and 2. So we remove 5 and 2. And as you can see from the results, we have 13 and 8. So 13 is the greatest value to the right that we've seen so far. We move on to the next value, which is 3. Now, is 3 greater than 13? No, 3 is not. We move on to the value. Is 8 greater than 3? Yes, 8 is greater than 3. So we're looking at values that are greater than the values to the left of them. So the idea kind of permutates that the idea to the leftmost, this is the rightmost rather, to the rightmost are greater than what we've seen so far. And an easy way to solve this is to reverse our linked list and then traverse that. Let's see what that looks like. So as I kind of hinted during the problem review, one easy way that we're going to do is to reverse the list. And the reason we're reversing is if we have a value that is always going to be greater to the rightmost, then it makes sense that we've tracked it earlier and we can kind of watch for the largest values that we've seen so far. For instance, because we are constantly checking if values to the right are greater, we do not know the largest that we've seen so far. However, if we reverse our list such that we have 8, 3, 13, 2, and 5, we can always track that we've seen 8 and 8 is kind of the largest that we've seen so far, and then compare all of our values based on the largest we've seen so far. So for instance, if we've indeed seen 3 so far, now 3 is going to be the new head. For instance, we reverse the list and the head, this 8 is actually 3. Imagine this 8 is actually 3. Now, what we are going to see is that 3 is the largest because it's the head that we're starting with. If we compare with 3, it's essentially the same, so we do nothing, right? If again we have 3 here, 3 is still the same with the largest, which is the head that we've seen so far. If we have 2, 2 again is the largest that we've seen so far until we get to 5. Now 5 becomes the largest that we've seen and 5 is our only answer. So it's kind of like it is the reverse version we are doing, where essentially since we know that the largest values are to the rightmost, or we are looking for the largest values to the rightmost of each element, right? So the rightmost like at the end. So we are now going to base that, use that as the basis of our comparison and then eliminate our values off of that. Now back to our thought process. So if the first thing we're doing is reversing what we have, now that we've reversed, what we want to do is track the largest that we've seen so far and then keep only the largest that we've seen so far. So we're obviously traversing through the head of our linked list. Now the largest we've seen so far is the last value reversed, which is 8. Now we track 8, right? And then we move on to the next value, which is 3. Is 3 greater than the largest value we've seen so far? It is not. So we skip over 3 and move on to the next value, which is 13. Now 13 is larger than 8, so we connect the link from 8 to 13. We break the chain from 8 to 3. We do not want to keep that. And then finally we go over to 2 and it's 2 larger than 13. 13 is now the new largest number we've seen so far. No, 2 is not. So essentially we are left with 8 and 13. Now we are to return the items exactly as they appear in our given head. So the linked list were initially given were to return the solution in that order, and recall that 13 comes before 8 because we reversed it. So now we're going to do the good work of reversing this back to what it initially was. So there are going to be three major functions coming up here. First, we reverse our loop. we reverse our linked list, then we traverse the linked list to find the values that are the greatest, and then we reverse back. Now, speaking about complexities, because we are doing all of this reversal, taking it back, traversing, it might seem like it's going to be a lot, but actually it is not. So when we reverse, we have the first loop, and then we reverse. This is an O of N operation. Obviously, when you are looping through the entirety of a list with O of N. Now, after we are done with this, then we traverse our reverse list again to keep track of the largest numbers that we've seen so far, which is another O of N, because we are traversing the entirety of the length of the list. Now we are also traversing again to reverse back to the initial order of the list that we were given. This length could be as large as the initial linked list if, for example, there are no great numbers, if we are given 1 1 1. So our reversal could grow as large as the entire linked list, or it could not in this case where we have only two values. But remember, in complexities, we're only dealing with the worst case scenario. So this is possible to also be an O of N. Now, when we have an O of N plus an O of N plus an O of N, you see eventually an O of N solution. And for space complexities, we are not using any extra space. We are just cutting off the link to this. So we're not storing any extra things. So it's going to be a constant space. Now let's jump right into the code and see what that looks like. So as we showed during the code walkthrough, the first thing we want to do is define the function that reverses our linked list. So I'm going to call this reverse list and define the function. So we want to define our parameters. We want to define the previous, which is going to be the null, which is technically going to be the head of our reversed list, and of course our current, which we are going to be traversing, which points to our head. While our current is not null, what do we want to do here? So first we want to store the next value in a current dot next. So if we have 5 2 13 3 and 8, we're defining previous to be null, and we're defining that our current is our head. Our head is currently 5. So why this is not null, we are saying that next, we are defining another variable which is next, and next is pointing to the next value of current, which we can see from here is 2. Afterwards, we want to point the value of next to previous. So now current, which is 5, no longer points to 2, but now points to the value of previous, which is null. And our current becomes our next. Recall that we saved the next value here. So we saved this value, this pointer, in this next, so that we do not lose access when we change the pointer of our current. So now next or current is now 2 pointing to 13 to 3 to 0 to 8. So we still have access to our linked list. And when we continue this code, our 2 is going to point to, because 2 is now going to be the next current, so it's going to point to 5, which is going to be the next previous, and so on and so forth, and would have a reversed list. And what we want to do here is return previous. Now that that is defined, let's go over to our function and traverse it. So first I want to catch that head is not null. So if head is null, I just want to go ahead and return null. And we want to set head to the reverse. We want to reverse our linked list. And after reversing, we want to just go ahead and traverse. So recall in our walkthrough that we said the maximum value that we've seen so far is going to be essentially the first value that we have, air dot value. Our previous is also going to point to null, and our current is once again going to point to head. Now we want to traverse. Should be familiar with the process of traversing with a linked list at this point. So while our current is not equal to null, what we want to do here is now check if the current value, so that's current dot value is greater or equal to the maximum that we've seen so far. If it is, what do we want to do? We want to update the maximum value that we've seen so far to current.val, and we also want to update our pointer. Otherwise, we want to lose that value because essentially it's less than what we need, and it does not satisfy the conditions that we are required to satisfy. So previous dot next is going to be current dot next, essentially breaking that chain and skipping through. And let's not forget to also increment our code while we're at it. So we move on to the next value in the array. And then once this is done traversing and we've gotten to the last item, we want to reverse that list again because we are to return our list as was given. So we reverse the new list that we have after eliminating the values that do not satisfy this condition of maximum seen. So we reverse the head. Now let's run that, actually submit. Right, so let's remove this walkthrough and then just submit that. So we can see that we get this error where essentially we cannot read the property of air.val. So it just basically says that there is no value, and that means there is something wrong with our head while that's been reversed if we no longer have access to the value. So now if we go back and debug, we can see that we are returning previous. Previous is null, but previous doesn't have any value here. We are essentially not storing previous at all. So previous is null. We're simply returning previous. While our code is reversing, we are not storing it in previous. So this is going to throw a problem because there is no value, there is no value. So what we ought to have done was set the value of current to our previous because that is what we want to do. So if you recall that little diagram that we showed changing the pointers, so previous is supposed to become the new current value. So now let's submit this once again. And we've already gone over complexities already, and voila, that's accepted. So thank you so much for watching this video. I hope that it was helpful to you. Do leave a like or comment with questions or any other comments that you may essentially have. See you in the next video. Bye.